Okay, so welcome back to our third video on 4.12, and we'll pick up right where we left off. We're proving that this expression is a sentence. So far we've gotten here, so feel free to pause and pick up the thread from where we've got it here. But basically what I want to do now is I want to take this whole guy, surround it in parentheses, right? And I want to add the universal quantifier onto it. X does not occur anywhere in here, so we're good to go. And that is going to be QS9 applied to line 4. And of course I have to replace at least one token in here. Now I conventionally let my X's be A's, so I'm going to replace all the A's. Okay, so now I've got this expression. And then what I want to do is I want to just keep building. So I want to build this thing and then this thing. So next stop is, GB, okay, implies. So we're doing the arrow rule, which is going to be QS7, and this whole thing, okay, which is a sentence. We just proved that. So that's going to be QS7 applied to lines 2 and 5, all right? And then, of course, what I want to do is I want to apply my existential quantifier rule, QS9, to this entire line. So I'm going to take this entire line. I'm going to surround the whole thing in parentheses. I'm going to attach my existential quantifier. Okay. And then what I'm going to do is I'm going to make sure that the Y doesn't occur anywhere in here, and it doesn't. And then I'm going to replace the B's. Okay. So this one required a little bit of planning. Okay. So this is QS10 applied to line 6, and that's QED. This expression, whatever it means, is in fact a sentence for us. Okay, this is constructible. Now, what kind of sentence is it? It's an existentially quantified sentence because this appeared in the last line. Okay, now if I asked you to prove that like this was a sentence, okay, obviously you would build this whole thing. Then the next step 8, you would do what would it be? QS6 to add FA from 1. Okay, but this whole sentence would be a disjunction because that would appear in the last line. Okay. So always note that. What kind of sentence am I looking at? That's crucial. Is it a universally quantified sentence, existentially quantified? Is it a brute sentence, right? Is it a conjunction, a disjunction? Is it a conditional, a biconditional? Okay, those are all those concepts remain important for us. Okay, let's try a couple more here. How about a sentence like this? Pause now and prove that this expression is in fact a quantificational sentence. Okay, once again, I'm going to adopt the convention of letting my X's be A's, my Y's be B's. So maybe I'll start off with A is identical with B, and that's going to be QS3, right? And then, of course, I can get my GAB if I like, and that's going to be QS2, my relational constant rule. And then after that, I want to get the negation here, so we'll go ahead and do it this way. Not identical with B, and that's of course applying QS4, our negation rule, to line 1. All right, and then of course we want to start building these things up. So we'll take this one, okay, which we just showed was a sentence, and we'll apply We'll apply QS7, our conditional rule, okay, like this. QS7 to lines 3 and 2. All right, and now that we've got that, it's a matter of tacking on our quantifiers one at a time. So let's just do this the fast way. Okay, first what we're going to do is we're going to tack on our universal Y quantifier to this, and we're going to be replacing the Y's but not the A's. So it's going to look like that, okay? And that's going to be QS9 applied to line 4. Then, of course, what we're going to have is QS9 applied yet again, but this time to line 5, okay? And the X's are going to replace the A's. Okay, let's try one last one here, just to make sure you see it and so you're ready for it on the homework. how about this big expression here where we actually have three quantifiers, and even though we're not covering meaning, okay, this absolutely is a sentence, but this means that identity is transitive, right? If x is identical with y and y is identical with z, then x is identical with z. So that's actually the meaning of that one. And if you studied, 4.11, where we talked about the formal properties of relations, you'll probably recognize something like this. So here all we're doing is trying to prove that it is in fact a sentence. In chapter 6 we'll prove that that's a theorem of logic as well, but it is a sentence. And pause now and try to show that this big expression with three quantifiers is in fact a sentence. Okay, so what I'm going to do strategically is say that x is A, y is B, and z is C. Notice I can't start with x, y's, and z's, right? It's got to be individual constants, okay? So first thing I'm going to do is I'm going to need A is identical with B, B is identical with C, and I'm going to need A is identical with C. So sort of like, okay, let's just build these up and get those out of the way. So I need A is identical with B, I need B is identical with C, that's this one and this one, and I also need A is identical with C, that's that one. So I need A is identical with C. All right. I don't know if I'll have enough space for this, but we'll try it. So that's going to be QS3 for all of these, okay? So it's going to look like this. All right. Okay, then what we're going to do is we're going to start building this thing up nice and easy. So first thing we'll do is we'll build this particular guy. So we're going to get this, and it's this one and this one. Okay, and so what is that? That's QS, let's call that QS 5, right, which is our conjunction rule applied to lines 1 and 2. Okay, now what we want to do is build up, this whole thing here. So what we're going to do is we're going to take this whole thing, put it like this, put it in parentheses, okay, use our arrow rule, which is QS7, okay, to get the arrow, and we're going to arrow it with what we have here. A is identical with C, okay? So that should be in parentheses like this, and that's going to be QS7 applied to lines 4 and 3, okay? So we're building this thing up pretty good, and then it's just a matter of tacking on the quantifiers in progressive order, okay? So what we're going to do is we're going to start by taking this whole guy here, surrounding the whole thing in parentheses, all right, like that, and then we're going to add the z quantifier. Z does not occur in line 5, so we're okay on that. And then we're going to call that QS9 on line 5. Of course, z has to replace at least one thing in here, and our strategy was to let it be the c's. So we're going to have the z's replacing the c's and nothing else. Okay? And then, of course, what we do is we take this whole thing, surround it in parentheses, add a quantifier on there. Okay, you get the point and the pattern, all right? So this is going to be y. Y is going to replace our b's as per our strategy, okay? And we get an expression like that, and that's QS9 applied to line 6, okay? And then, of course, what we're going to get is the final one, which is this whole guy here. So basically we're taking line 7 and we're putting the whole thing in parentheses, and then surrounding the whole, like this, putting the x quantifier on here, okay, and replacing the a's, okay, and that's going to be, what is that? That's QS9 applied to line 7, okay. All right, so I hope that that makes a lot of sense to you. This expression is, of course, a universally quantified sentence. This is the one that we used last, so it's a universally quantified statement, okay? All right, make sure you're trying the problems, all right? Make sure you're getting down how to make these constructions, which kinds of constructions are possible, which are not, and what kind of sentence am I looking at? Is it universally quantified? Is it a disjunction? Is it something else? All right. Okay, logic fans, we'll catch you on the final videos for chapter 4, 4.13, where we talk about the meaning of identity expressions like these. See you there.